right, hey SecretCon, how's it going? Thank you, thank you, thank you. Closing up SecretCon, SecretCon 2, SecretCon 1, SecretCon 2024. My name is Traxler. I'm kind of nervous today. Like closing up the hometown conference is really an honor. Thank you so much for sticking around to this presentation. Do I know how to advance slides? I don't know. Microsoft would like to allow, okay, sure, allow. Yes, we got it, fine. Allow. Yes, okay. I'm a cybersecurity researcher who struggles with PowerPoint. And I just thought maybe about what is a cybersecurity researcher, because it's a really odd job, right? It's a weird world, and I feel like it's, I was inspired by Mr. Christmas's talk earlier, where it's like I was a pen tester, but I got tired. I just got tired, and I just wanted to like sit on the Barca Lounger a little bit more. And that's kind of, reading Twitter is part of the job. Reading old Git commits is part of the job. Previous careers, I've done architecture, pen testing, secure code review. I built web apps. That was not a good idea. But now I'm really fortunate that people pay me just to do cybersecurity research, which is a very niche. Even more niche, cloud security research. Even more niche, to even pigeonhole myself even further, Google Cloud security research. And then if I really want to make sure that I really have no job possibilities, I am in Google Cloud security research. It's like it's like my sweet spot. So that's me. And I can advance slides, cool. Today we're going to talk about something that is not that fun to talk about. It doesn't make for a good blog post. It doesn't really make for a good presentation, I'm sorry, because presentations like to have this format where you have like the existential threat, and then like tactically how the attacker would abuse it, and like what your impact would be, and then this nice little bow of how you can prevent it. This has none of that. This is just like all the things that are going to go wrong and you're going to have no idea. And the mitigation slide is blank. There is just no detection. There is no mitigation. I'm so sorry. This is just happening and you're going to have no idea. And I uncover these things through my research into the clouds. Specifically because I like to say, well, how can the customers of my company detect, identify, how can we protect them? And sometimes it's just like a big goose egg. Sometimes it's just like, wow. So that's what we're going to do today. We're going to talk about things that you can't do anything about. This idea that they're all working as intended is like both a it's like a tongue-in-cheek thing amongst the cloud security community that we all say like all of these things are working as intended, but it's also like the direct response from vulnerability reports. When you report some of these things, right, the status that they change your ticket to is working as intended, or intended behavior in the case of Google. So what you're not going to find here is you're not going to find me with like a bunch of CVEs, because as a cloud security researcher, we just don't get them. Vulnerabilities within the cloud are not considered reportable to MITRE in AWS and GCP. Big asterisk around Microsoft, because that just recently changed. But the things I'm going to talk about today are a little cuter. They're feature abuse, meaning that the providers created a feature and somebody's just being bad. And they really just shouldn't be so bad with it. And if they just weren't so bad, everything would be fine. But it doesn't rise to the level of a CVE, right? And it all falls within the customer side of the shared responsibility model. It all falls within like, I'm a provider, I'm AWS, I'm GCP, I did my thing, I tossed the bomb over the other side of the wall, and whatever you do with it is kind of your deal, right? If you needed to detect something, that's kind of your deal, unfortunately. So that's how we get this moniker of working as intended. Will be on my gravestone, working as intended. The big kind of overarching undetectable that's ubiquitous across all three major clouds is data movement between services. You'd hope this is a thing that is really detectable, yeah? Like I should be able to know if my data is moving to a bucket I don't own. And it's weird, like if you look at breach reports and if you look at some of the, I'm just thinking like breaches.cloud, some of the other like GitHub lists that maintain these lists of publicly cited breaches in the cloud, look at how many talk about data exfiltration. Like one. There's like one reported or two reported cases. Why? Because I'm gonna show you, you wouldn't know. You really wouldn't know, because what we're talking about here is the movement of data from one bucket to another, from one storage account to another. It's not coming onto an attacker's endpoint. It's not moving over the public internet. It's moving on the backbone of the service, right? All right, so the ability for you to know that that has happened to you is just not there. So to be really clear, what you're going to see when data is moved from bucket to bucket, what you're going to see is a GET request. You're going to see that GET object, that somebody accessed your object. And that log is going to be written within that affected account, that affected project, that affected subscription. That's where you have the logs, that's where you're monitoring, and you're going to see some principal looked at a log or looked at an object, that, that thing with words, the thing with words that is important to you. Somebody looked at it, right? Somebody may have navigated to the console and triggered that event. Somebody may have downloaded to their endpoint. Also, somebody may have hijacked it off to a bucket that is hosted in AWS China, because the corresponding log that shows that bad bucket, that unknown bucket, that log is not written in your account, right? That log is written in their account conveniently. Actually, not conveniently at all. So, in a malicious scenario, in that feature abuse scenario, an attacker is grabbing an object. They're getting an object. That's nicely written. But when it's then put to the bucket, the destination bucket, the malicious bucket, that log is in the attacker-controlled account. You honestly would not know. So at the end of the day, what can you say about data movement? What can you say about movement of data? Can you say that you just didn't have the logs for it? Or do you just say you just didn't have any evidence that customer data was impacted? Probably the latter, right? And so there's just, so all's well that ends well, I guess. Exact same thing in GCP, and I really don't want to nitpick on just AWS and GCP. This is the same with Azure. You have the method storage object.get. That's going to be recorded in that victim account. Though that's where your detection engineers are going to have their logs. But what is that really telling you? That could just tell you that some absolutely authorized user navigated to the console and looked at a file. It's not going to tell you that it was then copied to Abu Dhabi. That's not going to say, because that record of the object being created, copied and rewrited to another malicious bucket, that log is written in that destination. There's a little bit of a caveat, and I hate to put a caveat here, because there's one incident that we can all think of in AWS that is striking. And whenever anybody thinks about it, they're like, oh yeah, that's the one people talk about. Could anybody think about the one AWS breach that is on the tip of everybody's tongue? The Cap 1. Everybody's like, Cap 1, yes. Capital One breach. The exfiltration of data from one bucket to an unknown malicious bucket. There was only one random ass reason they knew that was happening. It's because they made one little data event selector in their logs. So instead of saying, please collect the logs for these enumerated buckets, this bucket, this bucket, this bucket, they selected this box that said all current and future buckets. What that does on the back end is that creates a star, and this is this like random weird little bug in AWS that means that collects the scope for everything and will actually write the log into the victim account. So they happen to randomly know that there was a malicious destination in the Cap1 breach. It's a weird quirk of AWS logging scope logic that they ever knew. And this is the only one that I can think of that we really have had surfaced around data exfiltration is the Cap1 breach, because they happened to select the box that said, please grab me all events for all current and future buckets instead of enumerating them out. So my recommendations, there are none for detection. As I mentioned, you won't know that this is happening. Maybe that's why data perimeters are becoming like a really hot topic. You go to any, cloud vendor, you go to any like AWS Reinforce, reInvent, they are pushing their data perimeters. And basically this is going to be like a layer 7 control around defining exactly who can move data between buckets, between resources on their backbone. Much harder said than done, right? I'm not going to pretend that this is at all feasible for even a small piece of organizations out there, but for maybe your crown jewels, this is the way you have to go, because identifying when data movement is happening is just not feasible. So I've given you like the really bad news about data movement. I will now give you the really bad news about credentials, specifically about HMAC keys in Google Cloud. I think if you read some of the breach reports about cloud breaches, it's like the #1 initial compromise vector is access keys. People committing access keys, putting in the GitHub, yada yada, happens every day. The equivalent to AWS access keys in Google Cloud are these HMAC keys, right? They're just like this weird holdover, long-term durable credential that can be associated with users, used to sign requests programmatically, and those requests can be valid for up to 7 days. One little caveat is that they're not quite as devastating, and that access keys in AWS can be used to access literally anything, but in Google Cloud they can only be used to access storage. So how does this work? A user goes and generates an HMAC key. By the way, you would never know because there is no log. Oh, I know. Oh. A user signs a request to either access storage or to move some storage objects. Whatever request they want to make against their storage objects. They can create that request. It can be valid for up to 7 days. Again, you would never know because it's a local operation. It's not going to be logged. What you're going to see in logs is just objects being accessed. Again, that GET request, not the copy, not the create, not the rewrite, just the GET, and that's likely from just an authorized user that you'd expect. So the visibility is pretty rough here. You're not going to have visibility into the creation of the credentials. You're not going to have visibility into their existence, even their pure existence. You're not going to have visibility into the rotation. Yeah, that's about it. Zero idea that this is happening. I'm trying to think, what else do you have no idea that they are a per user credential that does not have a public service, rather is proxied through the console API. And as you might expect, I'm going backwards now, we're going to go back in time, This was marked, I don't mean to be sassy, but sometimes it's like this job makes me be sassy. It was marked as working as intended from Google Cloud. So this has gone through disclosure, worked with the teams to try to understand the impact and why they might not want to have completely invisible, ungovernable keys. And it is working as intended. My hope here is that I can skip the slides for a little bit. We can generate some HMAC keys. We can access some storage objects without logs. And then we can try to do some containment, right? So like, let's pretend that a defender would have some idea that this data access is suspicious and they need to move to containment. So again, the defenders, all they're gonna see is that like storage.objects.get. We're in a world that says that that's suspicious, so we're going to contain. What are they gonna potentially do? They're gonna cut access to storage maybe. Well, let's do it live, we'll figure it out, let's see that that works. Maybe we're gonna even deactivate the user. We're saying, oh, this is way too suspicious, we're gonna just deactivate the user and see what happens. And then, I know what happens for 2 and 3, FYI. I don't know what happens to 4. I'm really curious because rotating the password of the compromised user should invalidate all of the OAuth tokens, but this is not an OAuth token. So we're gonna find out live. Let's get out of here and figure out what's going on. Okay. See if I can switch over to. Well, I kind of screwed myself on this, didn't I?
I'm touching stuff.
Oh, thank you. Appreciate you. Let's see, what are we doing? We're going to generate an HMAC key. Woo-hoo. Hello. 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 Okay. Thank you. Appreciate it. Yes. I am in the Google Cloud Project Nanook LOLs 2020s, because it's just the time it is. We're going to generate an HMAC key, all right? Again, what is this key? It's a long-term durable credential. You're just going to have to trust me that no log was generated from its when I hit the button. No log is generated when I hit the button to delete it. We're just going to create and delete at will. Warning, if you do point some automation at this, you can generate hundreds, if not thousands, of these keys. You can't as easily, yes, you cannot as easily delete hundreds and thousands of these keys. Just a word of caution. So what we're going to do here is we're going to take that key here, and I made a small Python script that's going to take the key, it's going to take the key ID, and then what it's going to do is going to create a authenticated request to this bucket I created, and the authenticated request is going to use the signature v4, SIG-v4 headers. That's an authentication scheme that's commonly used in AWS. So the underlying purpose of these was actually for interoperability between storage in AWS and GCP. So they have this credential in order so that a client can interopt, TLDR. But here we go. Okay. Okay, what are we doing? We are going to do the Python script. We are going to do that. We're going to give it the access key, this access key here. Okay, we are going to give it a secret key. Give it a secret key. And then we also need to tell it the bucket and the object, because this is a GET request. So let's see, object. Let's see what's going on with here. Let's go over to my bucket. Bucket. All right, let's sample data. Ta-da. And the bucket. And then once we get the data, we're going to have fun with containment. Bucket. All right, did I do this right? I got an access key, I've got a secret key, I've got an object name. I spelled Python right. Let's find out. Okay, cool. It returned a curl request to me. I'm going to just copy pasta this back in. All right, so this is the money shot. There we, oh, well, crap. Hold on. What's going on? Okay, there we go. Oh, hold on. Let me do, craft that out. There we go, okay. The document says, organize the world's information and make it universally available. So that's our document. The Python script I have signs this for 7 days, so we can just keep on going and have a bunch of fun with it. But that's not really the fun part. The fun is in containment, because our scenario is, oh no, this GET request is bad. Oh, what do we do? So let me just flip over to the admin console here. Let me see my user. The first idea that I was going to go through is the suspension of the user. Let's go over here. Let's deactivate the user. Not delete the user. We want to deactivate it. Yeah, suspend the user. Sorry. So we're going to suspend the user. Seems like a pretty draconian thing, but we're going to do it. We're going to suspend the user. The curl request, and it's cut right away. Sometimes I can pull data for a little bit. Sometimes it's cut right away. So there is something there that says, like, is this user even valid? So that's a cool containment method. Okay, let's get it back on here. I got to refresh. Then let's see here. Reactivate the user. Yes, reactivate the user. Okay. Again, I'm going to just try to access that object with the same header that I generated 3 minutes ago. And we should be able to get it here pretty soon. There we go. Okay, so now we're back. So it didn't kill, it can't possibly kill the locally assigned header. That's not going to happen, but it does temporarily, at least, stem the bleeding. This is the same for cutting access, right? So your user has access to storage in the first place, you cut it. Any signed headers that you have are going to be cut, but the second you give that access again, you're going to see the header valid again. Now here's the fun part. I don't know what's going to happen if we try to change the user. I have a suspicion that it's going to do like literally nothing. Or if we try to change the password, it's going to do literally nothing. I have a feeling we're still going to be able to get this. So let's try this. Okay, so click on this thing, go to here, reset password. Okay. Should I be like official and do this? Let's be official, okay. Yes. Sure. Good. Check. Save. Copy. Yes. Done. Okay. Reset. Good. I've reset the password. Done. Don't save that. Cool. Now, I don't know. Yeah, it's still fine. So that's what I would have thought. Because what that's going to do is it's going to invalidate all of your OAuth tokens and force the person to re-sign in again. But again, we're not using OAuth tokens. We're using this right here. Authorization header, credential, here it is. Here's the credential that's used, and here's the signed, here's the signature. That tracks. And back to the theme of the talk. The theme of the talk is like, what could we see? All we're seeing here is the GET request. Let me just go over there and I'll show you. console. Logging. Yes, let's see more of this. Yeah, objects.get, 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 objects.get. It's just, we're just getting objects over and over and over and over and over again. Again, you could sign these requests to move objects. Anything in the storage realm is fair game. Makes sense? Cool. Okay. So now we know what the response will be. If you even have any indication that you need to respond, that user just needs to go away forever, honestly, or at least for 7 days, until you can assume that a signed header has timed out. There's really no other safer way to do it. I know this talk can be very bleak, and that's why it's not very fun. And so you might be asking, what about like the SLAs of logging? Are there some guarantees that say I should be getting logs as a consumer? That was my initial thought. But after pouring through SLAs and talking to a lot of economists of the cloud, you know, the SLAs are really there to guarantee uptime. Like, if there is a log, they will ensure that you get it within a certain amount of time, you know, sub 5 minutes or 10 minutes or whatever that SLA is. It's not there to guarantee that you get an event. It's not there to guarantee that the event is valid or useful. It's there to make sure that you receive something in a appropriate amount of time. I did mention that there was a little bit of a caveat around the transparency of these feature abuse issues. And that happened just yesterday. A very cool thing happened with Microsoft. Just yesterday, Microsoft seemingly bowed to some amount of pressure. I'm thinking they got a little heat from the Cybersecurity Risk Board, and they're now going to be issuing CVEs for cloud issues because they have changed, MITRE has changed the definition of when and how CVE numbering authorities should assign and disclose a vulnerability to include this little clause that says if something has the potential to cause harm. And Microsoft is now choosing to interpret this as the reporting of cloud vulnerabilities. So a bunch of us cloud security researchers are going to be like, we're going to get so many tattoos. We're just be like CVE, 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 CVE. Actually, I don't work on Azure, so I'm just out of luck, I guess. But this has hope of having some more transparency in the process. They haven't issued one yet. We haven't seen AWS or GCP follow suit, but it was a very cool development to see yesterday. It's a very cool development to see the movement from shared responsibility, which is like, I'm going to throw this bomb over the wall, good luck, to shared fate that says it does actually matter if the customers have impacts, because we sink and fall together. So that's all I have for you today. I hope you've potentially learned that you might be SOL on a few things. I apologize. There's a question from the back. Yeah. Yeah, how they define significant harm. So no, we don't know yet. This just came out yesterday. There was an update to MITRE's documentation that says around when CNAs should publicly disclose. The new line is line number 1 around potential harm. Nobody has really pushed what this means yet. Nobody really knows. So this is uncharted territory.
Coming from MITRE, I would guess that it is directly related coming from critical infrastructure, and so they likely are being disinformed.
Microsoft has put out a statement yesterday saying that they are taking this to mean that they are now going to be publishing CVEs in their cloud services. Cool. We'll see what happens. I love the thought, and we'll see what happens. Yeah. That's all I have for you. Thank you so much for attending. And listen, if you have any other questions about cloud or security research, my name is Kat Traxler. Please feel free to connect with me later.